Was the Sherman really the best tank of World War II? In 1941, the United States needed a tank that could be built fast, repaired easily, and survive on any battlefield. The result wasn't the strongest or the most heavily armored, but it was the most reliable. This is the story of how the M4 Sherman, powered by a radial aircraft engine and produced in over 49,000 units, became the mechanical backbone of Allied victory. From its unique suspension system to its cast hull variants, the Sherman wasn't just engineered, it was optimized for a different kind of war. And despite German tanks being more advanced on paper, it was the Sherman's simplicity and availability that changed everything. The Sherman's design reflected a balance of production speed, combat effectiveness, and adaptability. Early models featured a 50.8mm cast glacis sloped at 56 degrees, offering 90mm effective thickness. Later variants improved protection with a 63.5mm plate at 47 degrees, eliminating vulnerable hatch areas. The hull combined cast and welded elements, optimizing strength while minimizing labor hours. Turret evolution followed the same logic. The T-23 turret, introduced with the 76mm gun, improved crew survivability and firepower without compromising production. Material choices, rolled homogeneous or cast steel, were made for durability and speed. Inside, the five-man crew operated in a compact layout designed for efficient communication, movement, and ammunition handling, crucial under fire. This integrated approach to armor geometry, material composition, and crew ergonomics allowed the Sherman to absorb upgrades and maintain reliability across theaters, from North Africa to Europe, and stay battle-relevant throughout the war. At the heart of the Sherman was the Continental R975, a 9-cylinder radial aircraft engine adapted for tanks. Producing 400 to 450 horsepower at around 2,100 RPM, it delivered a power-to-weight ratio of 12 to 13 horsepower per ton, enough for fast tactical movement. Though fuel-hungry by nature, early models used the vertical volute suspension system, VVSS, with narrow tracks, which focused weight and limited off-road traction. To counter this, later Shermans, especially the M4A3E8, adopted the horizontal volute suspension system, HVSS. This system included wider 23-inch tracks, cutting ground pressure to roughly 11 psi and dramatically improving performance on mud, snow, and uneven ground. On roads, the Sherman could reach 30 miles per hour, with off-road cruising speeds between 17 to 20 miles per hour. This mobility enabled rapid flanking, redeployment, and exploitation of breakthroughs, key advantages in dynamic operations. Together, the engine and suspension system gave the Sherman a unique edge. It wasn't the fastest or most agile, but it moved well enough to win where it counted. The Sherman's armament evolved in direct response to changing battlefield threats. Early variants carried the 75mm M3 gun, a 40-caliber weapon firing 6.6 kilogram shells at 610 meters per second, enough to penetrate 100 millimeters of rolled homogeneous armor, RHA, at 500 meters. As German armor improved, later Shermans adopted the 76mm M1 gun, which raised muzzle velocity to 730 meters per second and improved penetration by 15 to 20% at similar distances. For close support, some models were fitted with a 105mm howitzer, firing 10-kilogram high-explosive shells ideal for bunkers and infantry positions, albeit at a lower rate of fire. Secondary armament included two Browning M1919 machine guns and a roof-mounted .50 cal M2HB, effective for anti-infantry and soft targets. Weapon mounts were carefully engineered for stability. Recoil systems minimized dispersion, ensuring accuracy under sustained fire. This combination of adaptable main guns, reliable support weapons, and precision mounting allowed the Sherman to fight both tanks and entrenched infantry, excelling in combined arms warfare. The Sherman's systems weren't just mechanical, they were communicative. The Sherman's fire control and communication systems worked as a coordinated combat suite. At the center was the turret-mounted SCR radio, connected via internal intercom to the commander, gunner, and driver. With a typical range of several kilometers, it enabled real-time coordination, critical for maneuvering under fire. For targeting, early Shermans relied on the M3 telescopic sight and a manual optical rangefinder. The gunner manually entered distance data and adjusted elevation, compensating for tank movement without modern stabilization. Despite these limitations, at combat ranges of 300 to 500 meters, Shermans could deliver 5 to 7 rounds per minute, effectively engaging armored targets out to 800 meters. This combination of reliable radio communication and calibrated optics allowed the crew to operate as a single unit, sharing data quickly and engaging threats with surprising precision. While primitive by modern standards, this system proved decisive in dynamic World War II combat, especially when paired with the Sherman's mobility and rate of fire. Despite its strengths, the Sherman suffered from a deadly flaw: ammunition storage above the tracks. Once penetrated by enemy rounds, especially 88mm shells, the resulting fires were catastrophic. This earned the Sherman the nickname Ronson, referencing a lighter's slogan, "Lights every time." In Normandy, field reports noted that many Shermans burned after a single hit, often with fatal results for the crew. Later models introduced wet ammunition stowage, dramatically reducing cook-off risk and improving crew survival. Still, the Sherman's mechanical reliability and speed were crucial. On D-Day, it was the tank that climbed the beaches first. Its mechanical dependability allowed Allied forces to exploit breakthroughs rapidly, even under fire. During the Battle of the Bulge, however, its thinner armor made it vulnerable to close-range German fire, despite improved tactics. In North Africa, the Sherman's lighter weight and desert adaptability became critical. It withstood heat, dust, and terrain better than many rivals, allowing the Allies to push forward, though often at high cost when hit. The Sherman may have burned, but it moved, fought, and endured. And the Sherman wasn't just a tank, it was a wartime production miracle. It wasn't just effective in battle, it was strategically affordable. Each unit cost about $33,000 in wartime dollars. Thanks to standardization and modular design, U.S. industry produced over 49,000 Shermans from 1942 to 1945. Production was spread across multiple factories using interchangeable components, minimizing downtime and repair complexity. Shared parts across variants, M4, M4A1, M4A3, streamlined logistics. Combat units reported over 90% availability, even under heavy usage in active combat zones, a striking contrast to the lower availability of more complex Axis tanks. While German tanks like the Panther or Tiger were more powerful, they were also costlier, slower to build, and harder to repair. The Sherman's low cost, high reliability, and adaptability gave the Allies strategic depth, ensuring not just initial strength but sustained pressure across fronts. In short, it was the tank the Allies could build fast, fix, and field at scale. The Sherman was never meant to outgun every opponent. It was designed to outlast, outmaneuver, and outnumber. From its smart armor layout and adaptable firepower to its economic efficiency and mechanical resilience, the Sherman was more than a vehicle. It was a system, an industrial and tactical answer to the complex demands of a global war. Its true strength wasn't in what it could withstand, but in how many could arrive, move, shoot, and fight again and again.